Hi guys, today I'll continue to discuss my theory on the Giza pyramids. In an earlier video, I point out that the large-scale shafts and underground chambers on the Giza Plateau might belong to an ancient underground mine. These shafts are very close to the pyramids. The tool marks at the Osiris shaft, the other shafts on the Giza Plateau, and the underground chamber in the Great Pyramid are all very similar. They resemble modern mining machine marks. It's conceivable there was a fundamental connection between the Giza pyramids and the underground mining system. By comparing today's mining operations with the Giza complex, I propose the theory that if the ancient shafts were excavated for mining, then the pyramids could be carefully designed and supremely structured, cemented mine tailing and waste rock storage piles. If this is the case, then what were they mining? Plus, did the ancient mine shafts generate enough waste material to build the massive pyramids? The Great Pyramid was built with an estimated 2.3 million big blocks and weighed 6 million tons. The Khafre is slightly smaller, but it's solid, so is the Menkaure. Therefore, the three Great Pyramids on the Giza Plateau together easily weigh over 13 million tons and contain over 4 million large blocks. So far, Giza shafts are basically off limits, so we don't know how extensive the underground system truly is. What we do know is that today's Giza Plateau is not in its original form. The top layer of the bedrock has been shaved off, and the terrain we see now where the Great Pyramids stand is essentially a man-made ground. Giza Plateau used to be much higher than today. According to a 2020 paper published on Heritage Science, the west side of the Great Pyramid is about 110 meters above the Nile, but that's not the original height of the plateau. The Giza Plateau was in ancient times geologically connected to the Mokattam Hill on the other side of the Nile. The other side of the formation, the Mokattam, on the east side of the Nile has an elevation of 200 meters above the Nile. The top level of the Giza Plateau, historically, might have been close to the same surface level, which is about 90 meters higher than today. Since the majority of the pyramid blocks come from local limestone, based on the sum of the masses of the pyramids, the researchers proposed that the height of the area could have reached 50 meters or higher than today. On the other hand, the rock foundation of the Khufu and Khafre pyramids are visible now. Scientists have found the existence of large original rock hill under the two Great Pyramids. The volume of this original hill is about 11.5% for the Pyramid of Khafre and about 23% for the Pyramid of Khufu. This is proof that the Giza Plateau had a higher altitude before. So the ancient people excavated about 50 meters of the rock hill, flattened it, and then used this material to construct the pyramids. This is a very strange and counterintuitive practice. The amount of labor and time involved to flatten the rock hill by 50 meters is incredible. The people who built the pyramids were very sophisticated, more so than us. If their goal was to build the pyramids, then instead of taking millions of tons of rock off the plateau and then use these rocks to build the pyramids, why not simply excavate the pyramids directly in the bedrock, then add blocks on top to achieve the ideal shape and heights? This would be easier and require less labor. Furthermore, the pyramids constructed whereby the lower portions of their bodies being bedrock would be more structurally sound than if constructed with blocks. Why didn't these very intelligent people create pyramids in a more efficient way? Why bother shaving the entire top layer of the plateau off and then use the excavated rock to build the pyramids? Taking off the top layer of a rock plateau requires a tremendous amount of work. The only activity I can think of which is comparable in our modern world is again mining. There is a similar practice in modern mine operations that also involves taking off top layers of rock hills. In mining, Overburden is the material that lies above an area that lends itself to economic exploitation, such as the rock, soil, and ecosystem that lies above a coal seam or ore body. Overburden is removed during open pit or surface mining, but it's typically not contaminated with toxic components. I think some of the structures on the Giza Plateau were built with overburden rock, which was not contaminated. By the way, it's common for modern mines to have both surface and underground mining portions. Maybe the multiple underground shafts by the pyramids were excavated for mining, as were the removal of the top rock layer, the overburden of the Giza Plateau. Since the goal was to get access to the ore, it makes sense to excavate a thick layer of stone. I propose the possibility that the ancients started a mining project on the hilltop going downwards, crushed and extracted ore on site, piled up waste materials along the way, then built waste storage piles with leftover materials, which became the pyramids. I think this is a more straightforward and reasonable narrative. This would explain why the ancients would flatten the plateau and then use the material taken from the plateau to build these gigantic pyramids. Some might ask, why would mine waste storage be built with rock cores? I think the reason could be that the rock hills can work as anchors or naturally enforced foundation stones, since the massive pyramids have no real foundations. Also, piling waste rock with worked ground is a common practice in today's mines as well. Current mining operations have their purchased land and operate within the premises. They also pay for annual fees for mine waste storage. Hence, if they can pile mine waste on a mining site, that would be more economic. By the way, the Giza Plateau is not that flat. The Khafre sits 10 meters higher than the Great Pyramid. Here is a side-by-side comparison photo of the Giza Quarry and a modern mine, two man-made places. Can you see the similarities here? Not too long ago, all the mine waste were dumped directly into rivers and lakes. This had disastrous consequences, but people in the past didn't understand the importance of treating and storing mine waste. If you told people back then they need to put tailings in the pond and build a huge dam around them, they would have laughed at you. Nowadays, however, the tailings pond is a common practice. The situation is similar to how people today might not realize how necessary it is that mine waste storage sites be built with accuracy. Our knowledge is progressing. We can't assume we know the best methods all the time. We changed from dumping waste in lakes to making massive tailings ponds. Now we have dry stack tailings and cemented tailings methods. Most don't see the necessity of carefully designed waste storage now, but maybe in the near future, we'll see such mine waste storage structures in practice. The Great Pyramid of Giza is the only one with connecting above and underground chambers and passageways, while other large-scale pyramids such as the Khafre do not have the same internal structures as the Great Pyramid. They have minimal openings and remain almost entirely solid, sitting on top of underground chambers. Even for the Great Pyramid, which has the most elaborate interior system, considering its overall mass, its openings only take about 0.014% of its entire volume, which means it's still predominantly solid. From a construction standpoint, it doesn't make sense to use so much building material to construct these enormous solid structures with so little usable interior space, unless the goal was to pack as much material as possible. It could be the pyramid's function, which was to safely store enormous amounts of blocks. So what kind of blocks needed to be stored this way? I can only think of one structure that fits this particular profile: mine waste storage. Multiple scientific papers have shown various material analyses that the pyramid blocks, including the casing stones, could be a form of concrete. So the pyramid blocks might be cemented mine waste. In the prior video, I discussed in detail the 6 similarities I found between the dry stack waste rock and tailing mounds and the pyramids. The link is in the description section. We can see the shapes and sizes of the two are very close. They are mostly solid structures with no foundations. They both have less permeable and buttress-like exterior layers. Plus, they are usually located near complex underground systems. If the Giza pyramids were mine waste vessels, then what were they mining? In the Osiris shaft, on the second level, there are areas with dark veins that look like iron oxide. On the bottom and third level, there is a rock tunnel with yellow-orangish coloration. This color is usually a sign of iron oxidization. We can see this tunnel looks similar to a mine tunnel. So were the ancients mining iron? One might think it's unlikely since iron is so common. Well, let's look for more clues on what the ancients could have been mining long ago. The Giza Plateau is limestone. What kind of ores can be associated with limestone? Not far from the Osiris shaft, by the funeral temple and the causeway of the Khafre Pyramid, there are areas with dark red and orange colorations. They look very much like iron oxide. The Russian researchers who pointed this out first thought the coloration could be the remnants of some ancient rusted-away iron or steel equipment. The areas with the dark red colors extended to an underground space. This space has similar machine marks like the ones we see inside the Osiris shaft, on some megaliths on the Giza Plateau, and in the underground chamber of the Great Pyramid. This underground space was covered up with stone blocks, and it seems a temple was built on top. Maybe the so-called temple was not a temple at all, but some utility building for the mining system. Here is a photo of a long, narrow shaft near the Khafre showing a similar iron oxide color. There are other pits also presenting the same curious colors. The Russian researchers collected rock samples from these areas in front of the Khafre Pyramid. By the way, we can see machine marks on the sites that they got samples from. Such markings are everywhere on the Giza Plateau if you look for them. So, the Russian researchers took the samples and did a series of studies to determine the minerals and their compositions. The researchers found that most samples are likely to be hematite and other ferruginous braids like limonite. Hematite and limonite are both important ores of iron. So were the ancients really mining iron here? I found another piece of evidence pointing to that possibility. According to the 2020 paper I cited before, X-ray diffraction was used to identify minerals on the backing limestone blocks and casing stones of the 3 big pyramids. It turns out that the limestone blocks, the core stones of the Khufu and the Menkaure pyramids, all contain minor amounts of iron oxides. The Khafre core stone contains rare amounts of iron oxide. Since we found potential iron oxide inside the Osiris shaft, the existence of possible hematite near the Khafre, as well as the core stones of the 3 great pyramids of Giza contain traces of iron oxide, it all points out to the real possibility that the ancients were mining iron on the Giza Plateau. Iron might sound mundane today as we're seeing and using it all the time. That's because iron is the most useful and important amongst all the metals. Some call it the backbone of modern civilization. Iron is the second most abundant metal in the Earth's crust, after aluminum. Here is a table showing the summary of the world production of metals. We can see that iron is the most mined metal in the world. More iron is made than all the other metals combined. Iron is primarily used to produce steel. Steel is used in manufacturing of automobiles, buildings, machines, power lines, pipelines, military equipment, electrical appliances, household appliances, and infrastructures such as bridges. In our world, prior to the Industrial Revolution, most iron was obtained from goethite or bog ore. Much of the iron ore utilized by industrialized societies has been mined from predominantly hematite deposits. The rock samples that the Russian researchers have tested suggest that there was hematite ore on the Giza Plateau. The civilization who built the super impressive pyramids were clearly very sophisticated. Besides the markings that resemble modern mining machines, there are also core drill holes and saw marks on the Giza Plateau, which are telltale signs of ancient high-tech machinery. From all this evidence, it's not a stretch to say that the pyramid builders probably came from an even more advanced culture than our own. Therefore, it's only natural for them to have realized and utilized iron. And because they were more technologically sophisticated, they would have better and safer ways to treat and store mine waste. Of course, there are also possibilities that the mining operation on the Giza Plateau was for some other precious metals or minerals, and the iron was a byproduct. After all, iron ore can be associated with other precious metals. Nowadays, among all kinds of mining solid waste, iron ore tailings are one of the most common solid wastes in the world due to their high output and low utilization ratio. Mining of iron ore has copious negative impacts on the environment. Mining practice can degrade and harm natural landscape, surface and groundwaters, as well as flora and fauna. Local water quality is contaminated as a result of surface runoff and leach that are frequently generated from large volumes of waste rock and tailings that are produced during iron ore mining. Uncovered by the mining process, the iron reacts with the air and releases sulfuric acid into the water. This causes acid drainage, and the process can last centuries. Acid drainage is a little-known global crisis. The UN has labeled it the second biggest problem facing the world after global warming. In the US, an estimated 22,000 kilometers of streams and 180,000 acres of freshwater reservoirs are negatively affected by acid mine drainage. According to a 1997 paper, worldwide, over $10 billion was used for treating acid mine drainage-related liabilities. In the United States alone, the mining industry spends over $1 million per day to treat acid drainage. That was 24 years ago. The numbers must have been increased a lot by now. To prevent acid mine drainage, the best way is to start early and in the beginning by eliminating acid drainage from happening. The formation of acid drainage requires three components: oxygen, water, and reactive rock, commonly found in a mine's waste rock dumps. Therefore, it's crucial to apply an impermeable layer to cover the mine waste piles. The extremely precise casing stones on the outside of the pyramids can act as an impermeable layer, waterproofing, to prevent surface runoff and water seepage getting into the interior pyramid blocks, which are possibly made of mine waste and tailings. The Egyptian pyramids are all located not far from the Nile River, which is the main freshwater source in a vast area. It's documented that the Nile has annual flooding events, which might have made controlling the runoff from mine waste a necessity, if not priority. It's possible that the ancients came up with a pioneering solution of cemented dry stack tailing storage, which was the construction of the pyramids so the Nile River and nearby settlements could be protected. Okay, from the studies I found online, it appears that the Giza complex could have been a mining site for iron, which is the most mined metal today. Perhaps an advanced ancient civilization designed a state-of-the-art mine waste storage method, which was intended to dry stack cemented tailing blocks into clean, simple, and stable pyramid-shaped structures. The ancients also covered the pyramids with highly precise casing stones to prevent acid drainage. Instead of being like today's slag heaps, which are eyesores, this advanced culture found an innovative and elegant way to store mine waste. By the way, we have just started to explore the dry stack tailing method with our mining waste. Maybe we can learn something from these magnificent Egyptian pyramids. It almost feels like we are on the path of catching up with this super developed civilization. Will our technology progress in a similar direction? What kind of future awaits us? If you have any insights, please leave me a comment. If you like my video, please give me a thumbs up and subscribe. Don't forget to hit the bell button so you'll be notified when I upload new videos. If you want to support me, my Patreon link is below. I have a wide range of topics that I want to share with you. This is Curious Being. I'm Tina. Thanks for watching and see you next time.